Hey, in this one I wanted to show you a library that I've been using quite a bit at work lately, and that has been, I don't know, a bit of a nice change in the way that I use messaging queues. So in the past I've used messaging queues in various kinds of ways. It could be like I have two threads, I need them to communicate. Oh, well, let's say this is Python threads thing, let's use the queue module from the standard library. And then the problem arises that, oh, something needs to communicate over the network, and I would still like to use message queues, but then you're like, oh, obviously the standard library doesn't work over the network, so let's use WebSockets or some other thing. And then you start looking at like message brokers, and they're all a bit different. And also it's kind of like, okay, if I have a broker, I have one more hop in my network, and so that can slow things down. Can I handle that, and so on and so on. And so while looking for solutions regarding this, I stumbled upon the ZeroMQ library, which is kind of like a library that does it all. Like, it's slightly harder to use than other messaging queue libraries that I've used, but it's quite rewarding once you know it, because it can do message queues between threads, between processes, on the network. If it's on the network, you can choose like what network protocol you use, so TCP, UDP. There's even like some kind of weird UDP schemes, but that do have some hack mechanisms you can do between VMs. There is also, they support the Unix sockets if you want to do inter-process communication, stuff like that. And it's all the same interface for all these kinds of stacks, let's say. So yeah, let me just demonstrate quickly what it can do and why I think it's quite a powerful library to know. And then in the next few videos, I'll get more in depth about how you can use it. So the first thing you need to do when you create when you want to use ZeroMQ is create a context. So by the way, here I have a little boilerplate thing. It's just so that I can Control C and the program will stop cleanly. But as you can see, the only thing you need to include is zeromq.h. So you start by creating a context. So the context is basically like the, let's say, ZeroMQ's backend. So it's where it will manage all the threads. If you have 50 sockets, that's how it's gonna like handle all the receives and sends under the hood and like transfer the message to the correct places and so on and so on. So you create a context by doing a ZeroMQ context new, like so. All the functions, like we're in C, so they will return a special value if there is an error. In this case, it's null, but let's not worry about that for now. And then you want to create a socket. In this case, this will be a publisher. Oh, so yeah, that's something I forgot to mention. On top of all these kinds of, let's say, transport protocols that you can use, there is also, on top of that, some like application protocols. So like a publisher and a subscriber, or a requester and a replier. This is not clear for now, but this will make our life easier in the long term. So let's just create a publisher socket, which is very simply just a socket that will send messages continuously. And it can have one or more subscribers that will receive the messages. So you create a socket by calling it ZeroMQ socket with the context, and then the socket type. So in this case, it will be a pub or a publisher. Then let's just have a little while loop with the running variable, like so. Of course, we're in C, so we do need to close stuff that we allocate. So for to terminate to free socket, it's ZeroMQ close. And to terminate the context, it's ZeroMQ context term, like so. Context up. And so let's just do a little printf. Up. Sending a message. And let's have a little counter like so. up, and then we will send a message. So the way you send a message is with ZeroMQ send, like so. So you specify the socket where you want to send your message, the content of the message, its size, and a bunch of flags. Let's not worry about the flags for now. And you can see, by the way, after me showing you all of this, this is very similar to the Unix sockets interface. Well, of course, there is no context for the Unix sockets, but the ZeroMQ socket is very similar to the socket syscall. The send function is similar to the send syscall, and the close is also similar. And this is a pattern that you will see. It's like the interface is inspired by the Unix sockets. So you send your message, and let's just do a little sleep, like so, to avoid overwhelming my computer. And this is the way you compile it. You just need to link the ZeroMQ runtime, and we can see that now we start sending messages. Oh, and I forgot one big step, is that, of course, right now we're not telling it where, like on which address we're listening. So we need to do ZeroMQ bind, again, very similar to Unix sockets, with the publisher, and then an address. The address is like kind of their own schemes, but it's based on regular URLs. So you specify the protocol, then colon // and then the listening IP, and then a port in this case. So let's listen on port 8080, like so. And so, well, nothing will change, but now there is an actual endpoint where stuff can connect to. So actually, let's run that in the background in another tab. And now let's focus on the subscriber. So this is the other process that will receive messages. So let's do that. Subscriber.c. Like so. Again, I have a little template here, but it just creates a context, and it has the little while loop, nothing more. So let's create a subscriber. Again, this is very similar to before. You just pass the context, ZeroMQ sub as the type, since this is a subscriber. This time I won't forget that you do need to connect. So like the publisher, you used bind to bind an endpoint to it. In this case, we need to use connect. Again, very similar to Unix sockets. Subscriber, and let's specify the exact same endpoint. So 8080, like so. And now let's receive a message. So to do that, you use ZeroMQ receive. You use a subscriber. When you need a buffer, so let's allocate the buffer later of 32 bytes. And there's the flags, which we don't worry about for now. Let's have a buffer of 32 plus 1 bytes. It returns the number of bytes that was read. And let's make sure we have a null terminator. Boom, 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 like so. And finally, let's just print that we received something. Let's print it like so. And print the buffer. And I also still forgot something. So since this is a subscriber, you need to subscribe to something. And usually the way this is done is that there is a topic. In the case of ZeroMQ, you subscribe to a prefix of the message. And so to subscribe to something, you do setSocOpt with a subscriber. The option is ZeroMQ subscribe. And for now, let's just subscribe to absolutely everything. So an empty string and a size of 0 is subscribing to everything. If you did not understand that, it's okay. I'll come back to it when I cover publishers and subscribers in more depth later. So now let's run our little subscriber. And you see, it works. It receives hello. So in the background, the publisher kept publishing messages in the void. And now that we have a little subscriber, you see that it receives the messages since it connected to this address. And so the cool thing is that, well, first of all, there is a lot of less boilerplates than if you would have done this in with the Unix sockets. One other cool thing is that the reconnection mechanism is handled for you. So let's say I Control C here. Oh, yeah, I forgot to ZeroMQ close the subscriber, but it doesn't matter. So here I killed it. It keeps publishing, so there is no error on the publisher side. And now I can rerun my subscriber, and all of a sudden it just subscribes again and receives the messages again. There was no, let's say, I didn't have to fiddle with like TCP options and so on. So this also works if like the publisher dies. So you see now I killed the publisher, so I'm not receiving anything, but it's still running. Like there is no error. And so if I restart the publisher, I start receiving messages again. And the whole auto reconnection, there's a whole auto reconnection mechanism that is working under the hood. So what you can do as well is that, let's say, I can have another subscriber. So yeah, I just have two subscribers now. And they both, every time the publisher publishes something, the subscribers will receive both the message. And again, there was no handling of like having multiple clients and having some kind of poll loop and any kind of these things. So yeah, let's start one. Let's restart this one. Here again, I can kill the publisher. Both of them receive nothing. And then if I restart the publisher, they start receiving messages again. And all of that was done for me. So yeah, this was the basic showcase of ZeroMQ. If you got a bit excited about this, feel free to watch the next couple of videos, which will cover in more depth publisher subscribers and other kinds of funky topics. So anyway, this is all for today, and see you in the next one.